Hey, Mr. Riley here with the next topic here in our discussion of ratios and proportional reasoning. We've talked about unit rates. We're now going to talk about proportional and non-proportional relationships. This little picture of Charlie Brown here, because Charlie Brown's a good example of something that is not proportional. Okay? Proportional is when things sort of match up from a smaller size and a larger size, and the bigger the thing gets, everything kind of stays properly aligned. And Charlie Brown's head is not proportional to his body compared with a real person. So that's why I use his picture. He has a very big head. All right, we're going to start on page 33, a little discussion about buying some pizzas. Okay, so Miss Cochran is planning a party and they offer free delivery and $8 for a medium pizza. Okay, so they ask you to complete this table here to determine the cost for different numbers of pizzas. Now, we need to start getting into the habit here, because you're going to do it for the rest of your math career, that when we have two things like this that are related, we are going to use variables to represent these two things. And typically, the most common variables to use for those are X and Y, letters to represent these changing numbers. So we're going to have X represent the number of pizzas here in this table, and Y is the cost. Okay, so just think about these are the X and the Y. So it says one pizza is $8, and we can fill in the rest of this table. It should be pretty simple. That two pizzas is going to be $16. Three pizzas is going to be $24. Add $8 again, $32 for four pizzas, and $40 for five. Okay, so for each number of pizzas, fill in these boxes, okay, to relate the cost and the number of pizzas, okay, and simplify the ratio. So simplifying ratios, that's something that you should be able to, that's simplifying a fraction. Okay, 16 divided by 2, well, that is the same as both of these are divisible by 2. And so that's the same as 8 over 1. Three pizzas and $24. If you did this simplification, each of these are divisible by 3, and you get 8 over 1. $32 was for four pizzas. And so that also, if both of these are divided by 4, you get 8 over 1. And lo and behold, the last one, the 5 pizzas for $40, also simplifies to 8 over 1. So the big question here, what do you notice about the simplified ratios? For all of these costs and number of pizzas, what do you notice about the simplified ratios? That's right, they are all the same. The ratios are equal. They all equal 8. Okay? This is an example of a proportional relationship. A proportion, and the relationship, and what we're talking about is the relationship between the two quantities, in this case, the number of pizzas and the cost. No matter what the number of pizzas and the cost, the ratio of cost to number of pizzas is always the same. It's always $8 per pizza. So it is a constant ratio or a constant unit rate, and that makes it a proportional relationship. If this ratio is not constant, then it would be non-proportional. We'll see examples of that here. Okay? All of these problems are going to give you two numbers that are related to each other, and as the one number changes, the other one changes, and we see what that relationship does as the numbers change. Okay? Andrew, in this next example, earns $18 an hour mowing lawns. Okay, and is the amount of money that he earns, is it proportional to how much time he spends mowing the lawn? Explain. And when it says to explain, what I want to see is the ratios and that they are all equal. That would be the explanation. Okay. So the number of hours that he works, we're going to call that the X. This is sort of the number you're choosing, right? Typically, it's just a count of things that go up, 1, 2, 3, 4. That's the X, the input, okay? And the output here is the amount of money that he makes, okay? So in 1 hour, he makes $18. If he works for 2 hours, he's going to get 2 times 18, or $36. 3 hours, $54, $4.70, 4 hours, $72. Okay, is this proportional? Well, what you have to do is you have to take each of these ratios, and you'll see how the book writes each one of them. Okay, they write 18 over 1, they write 36 divided by 2, they write 54 divided by 3, they write 72 divided by 4. And what you can really do is, instead of actually simplifying these fractions, you can actually just do all these divisions. That's another way to do these problems. And all of them, if they all come out to the same answer, then it is a constant unit rate, which means it is a proportional relationship. And these all come out to 18. So the answer is yes, it is proportional, because the unit rate is always the same. And this work right here, that's your explanation. Okay, the showing the ratios of the two numbers that go together and that they are all equal. Okay, so now here's one for you to do. At Lakeview Middle School, there's 2 homeroom teachers assigned for every 48 students. Is this proportional? Explain. Okay, so we're going to have to set up a table here. Okay, I guess. So if you set up a table and you did 2 students, and they would have 2 teachers rather, and 48 students. Okay, and then if we went and had twice this many, 96, 2 times 48, there would be 4 teachers. Okay, now this isn't how they expect you to answer this problem. I think because they're saying, well, no matter what, every time you add 48 students, you're going to add 2 teachers, and the ratio is always going to be constant. Okay, so it's always going to be 24 students for every 1 teacher. I don't particularly like this problem. Okay, it's not a good got it problem because it doesn't look like this example up here. And so I'm not going to really worry too much about how they got to this. One thing you can notice here, though, that's important. If there's only a number that goes up for every number that it's related to, in this case, the students goes up, the homeroom teachers go up for every time the students go up. There's not another number added on. That's going to be a proportional relationship. Okay. All right. Let's take a look at a different example. Here's example number 2. Uptown Tickets, they charge $7 for a game ticket plus a $3 processing fee. Okay, so this processing fee is not added onto each ticket price. You just pay that one time, $3, and then you pay $7 for each ticket. Okay, so the table here, depending on how many tickets you order, that's the numbers you're going to pick. That's your X. And the cost are the numbers you're going to calculate based on what they tell you is happening here. Those are going to be your Y values. Okay, so if you buy 1 ticket, that's $7 plus the $3 processing fee, you pay $10. If you buy 2 tickets, it's 2 times 7, 14, plus the $3 shipping charge or processing fee. That's where this $17 comes from. 3 tickets is 3 times 7 plus the $3. That's 21 plus 3 or $24. And 4 tickets will cost you 4 times 7, 28, plus the $3 processing fee, 31. Okay, so that's where this table comes from. Well, is the ratio of cost divided by the number of tickets, is that ratio always constant? Well, 10 divided by 1 is 10. 17 divided by 2 is 8.5. Well, right there, it's not constant. Okay, you don't even have to do these two, because as soon as you get 2 answers that are not the same, this 10 and this 8.5, as soon as you get those 2 answers that are different, you can answer the question. It is not proportional, right? All you have to do is show 2 ratios not equal, and then you can answer the question. Okay, that's your explanation, this work right here. Here's another one. Making a fruit punch. You use a half a cup of sugar for every envelope of punch mix, okay? So if you use 2 envelopes of punch mix, then you need 2 half cups of sugar, which is 1 cup. Okay, you keep adding a half a cup of sugar as you add a cup of envelope mix, and you get a table that looks like this. Now you can do these divisions, Okay, divisions of fractions, that's okay. We kind of skipped that unit, but that topic here, we'll get to it later. But you can do this if you can change the fraction to a decimal, then you can do the division in your calculator. Okay, I won't give you any with fractions in them. But just so you see here, 1/2 divided by 1, and then 1 divided by 2. 1 divided by 2 is 0.5. 1½ divided by 3, you could rewrite that as 1.5. Divided by 3 comes out to 0.5 also. And then certainly this one, 2 divided by 4, okay, that simplifies to 1/2, or if you divide it in your calculator, it comes out to 0.5. So these ratios are all constant. Therefore, this is a proportional relationship. All right, okay, so here's a got it problem that might be actually worthwhile here. So at the beginning of the year, Isabel had $120 in the bank. And each week, she puts another $20 in there, deposits another $20, so adds it in there. Is the balance, the amount of money in her bank account, proportional to how many weeks she's been putting money in? Well, 1 week, how much money does she have in? She started with 120 and she adds in 20 every week. That means that she has $140 in her account after 1 week. The second week, she adds 20 more dollars. So this now becomes $160. In the third week, she adds $20 again. So it's $180. Now, is this a proportional relationship? Now, this case, these numbers here, the X numbers are always kind of the numbers you pick, typically like 1, 2, 3, or 10, 20, 30, 40. Numbers that you pick are always going to be represented by the X, sort of the input or the starting value. And the number you calculate will be represented by Y. We'll talk more about this in the next few lessons, okay? So I'm going to do always the Y divided by X, the dollars divided by the number of weeks. So 140 divided by 1 is 140 for the first week. The next week is 160 divided by 2. What's that? That's 80, okay? Why is that all the work that I show? Why didn't I show 180 divided by 3? Because I don't have to. Because once I get two of these ratios not equal, that tells me the answer. What is the answer? This relationship is not proportional. Okay? No, it is not proportional because the number of weeks and amount of money are not a constant rate. Okay, here's another one with two different people doing some reading. Okay, Martin and Gabriel. Okay, which one of these is which one of these situations is proportional? The relationship between the amount of time that he spent reading and how many pages were read. Okay, so it shows you here that Martin reads 2 pages in 5 minutes, and then 4 pages in 10 minutes, and 6 pages in 15 minutes. Okay, so we can look at this and look at the ratio here. 2 divided by 5, that's 0.4. 4 divided by 10 also equals 0.4. 6 divided by 15, your calculator, 0.4. Now you could simplify all those fractions. They all simplify to 2/5. You can do this either way. It's probably easier for most of you to just do the division in your calculator and make sure all the decimals are equal. These all equal 0.4. Okay, which means Martin's reading is proportional because the ratios are all the same. What about Gabe? Well, he reads 3 pages in 5 minutes, 4 pages in 10 minutes, and then 7 pages in 15 minutes. 3 divided by 5 is 0.6. 4 divided by 10 is 0.4. Not equal. As soon as these are not equal, you answer the question. This one, Gabe's reading, is not proportional. His ratios are not constant. Okay, so the answer is Martin is the one with the proportional reading rate. All right, so that's whether figuring out whether something is proportional or not. There's 2 problems here on page 36. It's probably good to do in the lesson here since we didn't really get a lot of good got it problems. All right, so number 1, the Vista Marina rents boats. They charge $25 per hour, But in addition to that, there's a $12 charge for fuel. Okay, so is this a proportional relationship? Well, we got to pick some hours. So it makes sense to pick 1 hour, 2 hours, and 3 hours to fill out this table. Okay, if I rent the boat for 1 hour, how much am I going to pay? How much am I going to pay if I rent the boat for 1 hour? It's $25 for the hour plus $12 for fuel. So the answer is $37. How much am I going to pay for 2 hours? $25 per hour means 2 times 25, so 50 plus the $12 charge, $62. 3 hours, 3 times 25 plus $12. That's 75 plus 12, or $87. Okay, so now we have that. Is this proportional? Cost divided by hours is what we're going to look at. 37 divided by 1, that equals 37. But 62 divided by 2, 62 divided by 2 is 31. Okay, that's where this comes from. I probably should have written that in there. Okay, so this one is 37 divided by 1. That's this first one. And this one is 62 divided by 2. And that's where the 31 comes from. So they are not equal. They're not equal. That means that this relationship is non-proportional or not proportional. All right, let's look at the next one. Which one of these is a proportional relationship between the hours they work and the amount they earn? Okay, so it gives you Matt's earnings, $12 in an hour, $20 in 2 hours, $31 in 3 hours. We're going to look at all these ratios. So $12 an hour and then $10 an hour. Where does this $10 an hour come from? How did I get this answer? It's this 20 divided by 2. 20 divided by 2 is 10. These are not equal. Therefore, not proportional. Okay? Here, 12 divided by 1, 24 divided by 2, 36 divided by 3. Not sure why I didn't write all these out. Okay? Kind of bad. You add them in here. Okay? So on this problem, we were doing 12 divided by 1. Then we were doing 24 divided by 2, which equals 12. Okay. This one also equals 12. And the last entry in the table there, $36 for 3 hours. And 36 divided by 3 is also 12. Right? So they all come out to $12 per hour. Since they all come out to $12 per hour, the ratio is constant. That means that Jane is proportional. Okay? What makes two quantities proportional? The ratio of the two numbers is always the same. The unit rate is constant. That's the whole lesson. Okay? And you'll have some practice problems.